All right, here we go with objective 15, which talks about solving and graphing linear inequalities. This is the first objective of our third unit, talking about inequalities. The first thing that I want to say is that solving these inequalities is very similar to solving the equations. In fact, let's go ahead and write that. It's very similar to solving equations, but there are just some small differences. So, with small differences. So let's take a look at an inequality. Here I have this here. To read this off, we would say x less than 5. So we can write out x less than 5. Another example, if I have something that looks like this, I would read this as x greater than or equal to negative 2. X greater than or equal to negative 2. There are 4 different inequalities. The first is this first one that we saw, less than. If we flip it around, then we get greater than. And if we put a line underneath it for each of these, then we're saying less than or greater than or equal to. So this first one, less than with a line under it, is less than or equal to. And then flip it around, we have greater than or equal to. When we're solving these, we're going to solve these the same as before. So we're going to write that big and bold at the top. We're going to solve the same as before. So everything that we know about solving equations is going to be true for solving inequalities. But now we're going to get infinitely many solutions. One final note, this is one of the small differences that we'll see with inequalities. And you can put a star next to this, very important. When you multiply or divide by a negative, so when you multiply or divide by a negative, flip the inequality. And circle that, put a star next to it. That becomes very important. So I'll talk about what that means in one of these examples here. So looking at this first one, we have 4x is greater than 12. So we're going to solve this just like we would an equation. So 4x equals 12. In order to solve for x, we need to get it by itself. So we divide both sides by 4. And we have x, instead of equals to, equals, we're going to say greater than. And then 12 divided by 4 is 3. So we have x is greater than 3. That's our solution. Next up, we have this here. In order to solve for x, we want to subtract 3 from both sides. So are we multiplying or dividing by a negative? No, so we don't have to worry about flipping the inequality. We're just adding or subtracting a negative. Okay, so then these cancel. We have negative 25 minus 3 gives us negative 28. And so that inequality stays the same. And that's our answer there. Next up, we have negative 2x is greater than or equal to 18. Now here, a lot of students might see this and add 2, but notice that we have negative 2 times x. So in order to get rid of that times x, we have to divide by negative 2. Now, because we're dividing by a negative, see what happens. Well, these cancel. We have x. Because we're dividing by a negative, we have to flip the inequality. So instead of greater than or equal to, this is now less than or equal to. And then we have 18 divided by negative 2 gives us negative 9. Okay. So now we have looked at solving. I want to take a look at graphing these inequalities. So go ahead and flip the page. In order to graph these inequalities, I want to look at that first example that we had, x is greater than 5. In order to graph this, step 1 is to put your number and 0 on the number line. So put both numbers on a number line. So let's draw out our number line. We're going to put 0 right in the middle. And then our number, this number here, 5. Well, 5 is positive, so it's going to be on the right-hand side of 0. So we put both our number and 0 on the number line. Step 2 is to choose what type of circle for the number. So the two types of circles that we're going to be talking about, if it's less than or greater than, we're going to have an open circle. If it is less than or equal to or greater than or equal to, we're going to have a closed circle or a shaded circle. So looking at this one, here we have greater than. So this is not equal to, so we're going to have an open circle. And we're going to put that right on our number. So we have an open circle on 5. And then our last step is with the variable on the left. So with the variable on the left, make an arrow and shade. So I'll show you what I mean by that. Here we've got the inequality is greater than. If I were to make an arrow with this, so from greater than, an arrow would look like this. So this tells us the direction in which we're going to shade. So we're going to shade to the right. So you can draw squiggles. And then at the end of our shading, draw an arrowhead on there just to show that this is the shading continues all the way infinitely out into the right direction. Let's do another example. Say I have A is less than or equal to 3. So I draw my number line. I put 0 in the middle, and then I also put my number on there. So my number is 3, which is positive, so it'll go on the right-hand side. Choose what type of circle. Well, this is less than or equal to, so it's going to be a shaded circle or a closed circle. Now the variable is on the left-hand side of the inequality, so let's make an arrow. This is pointing this way, so we're going to be shading to the left. So you're going to shade all the way up to the left. And then again, I want to draw an arrowhead on my shading just to show that that goes off infinitely in the left direction. So let's solve a few more and we'll graph them. So here we have 5x minus 3 is greater than 29. In order to solve this, we first add 3. So these cancel. We have a 29 plus 3 gives us 32. And we didn't multiply or divide by a negative, so our inequality stays the same. And we'll bring down our 5x. Next up, we divide by 5. Again, 5 is positive, so we don't have to flip the inequality, right? Dividing by positive is fine. So that stays the same. And then we can't reduce this fraction. So it stays. That's our solution, 32/5. In order to graph this, let's draw our number line. 0 goes in the middle. And then is 32/5 positive or negative? It's positive, so it goes on the right-hand side, 32/5. We've got, it's not equal to, so this is an open circle. And then if we were to draw the arrow, so this is our greater than sign, we're going to draw the arrow, tells us to shade to the right. So we're going to shade to the right, and we'll draw an arrowhead at the end there. And that's it. Another example. So here we have 4x minus 3, the quantity divided by 9 is less than or equal to 2. In order to solve this, right, you might think reverse PEMDAS and you want to add 3. But before we can add 3, we have to deal with this 9. Because this minus 3 is trapped by this divided by 9. So we have to first get rid of that divided by 9 by multiplying both sides by 9. So we get rid of that divided by 9 by multiplying by 9. So now all that's left is 4x minus 3. Now, did we multiply or divide by a negative? No, we didn't. So the inequality stays the same. And then 2 times 9 is 18. Now we can continue to solve as normal. So we add 3 to both sides. So then we have 4x is less than or equal to 18 plus 3 is 21. And then our last step, we divide by 4. So if we divide both sides by 4, again, 4 is positive, so we don't have to flip the inequality. We have x is less than or equal to, we can't reduce that, so that stays 21 over 4. So graphing this, let's draw in our number line. 0 goes in the middle. And 21/4, that's positive, so it'll go on the right-hand side of 0. We're looking at less than or equal to, so it's a shaded circle or a closed circle. And then to draw our arrow, we're looking at the left-hand side. So we draw in our shading, and then we draw arrowheads. I want to return to the first few examples, so go ahead and flip back and we'll graph those. So returning to that first page, let's graph our solution here. X is greater than 3. So again, we draw in our number line. We've got plot 0 and plot 3. Well, 3 is positive, so that's on the right-hand side. X is greater than, so it's an open circle. And then to draw in our arrow, right, greater than, and we draw on the arrow, which means shade to the right. And draw an arrowhead there. Next up here, hey, what happened here? So we've got our x's on the right. So remember, in order to graph, we need our variable on the left-hand side of the inequality. So we have to flip this in order to graph. So you can put a big note there. Flip this in order to graph it. And so everything flips. If we want the x to be on the left, we're going to move that to the left-hand side. Right? We're flipping everything, so our inequality flips as well. So instead of less than or equal to, it's greater than or equal to. And then our negative 28 goes from the left-hand side to the right-hand side. So now we have negative 28 here. So this is the inequality that we're graphing. These are really equivalent, but we're going to graph this using our technique. So we draw on our number line. Again, we plot 0. And then our number, well, our number is negative, so it's going to be on the left-hand side of 0. It's going to be a closed circle because we have greater than or equal to. And then drawing in our arrow, it's going to the right. So we're going to shade to the right. All right. One more example. So here we have our x is on the left-hand side, so we're good. We can draw in our number line. Draw 0. And then we have negative 9, so that's going to be on the left-hand side. And we're looking at less than or equal to, so this is going to be a closed circle or a shaded circle. Drawing in our arrow, we have, so this is less than or equal to. Drawing in our arrow tells us to shade to the left. So we're going to shade to the left. Okay, so now we have solved and graphed all of these inequalities. This is objective 15. We're going to get a whole lot of practice on this. Have a great day, everyone.